Hello and welcome. My name is Schumann. I'm having today our Canon automation webinar on functional safety and CANopen systems, CAN-based systems. And like it, it is intended as a more general introduction into the topic for the next about an hour. Just a few words for the participants who don't know Canon automation and don't know me. Just a few words there. My name is Schumann. I'm an electrical engineer and I work with Canon automation on CAN-based systems for over 25 years right now. And over the time, I have been an expert in multiple standardization and different working groups on many different topics. We are on application level topics, on basic topics, and also on ground topics like safety, functional safety, and security, cyber security. Canon Automation is a non-profit organization which was founded in the beginning of the 1990s for the sole purpose to provide technical product and marketing information on CAN-based related products, services, on systems and alike. So we try to foster the image of CAN technology and to provide a path to future network technologies based on CAN. And we see that later in the presentation. We, over the years, have, together with participants in different fields and people in different fields together, improved on the CAN technology. But I will have a few words on that topic later. As a non-profit organization, we having members, which are companies, and those members are worldwide, with most of our member companies coming from Central Europe and in general from Europe, and also a big portion coming from North America. And new and upcoming is here also to mention the Far East, especially as China. As I said, Canon Automation was founded in the beginning of the 1990s. Since then, we have published our news in our CAN newsletter. So all the related updates and information on CAN-based technologies, we have presented those things also together with our member companies on different exhibitions and fairs, sometimes as a Canon automation booth, sometimes as a organized joint booth on the different topics. Over the years, of course, we have published many different specifications related to CAN, starting with the first release of our first specification related to the physical layer, and then later also on to mention on different application layers, mainly the CANopen layer, which we developed with our members over the last also almost more than 30 years. We also organize the International CAN Conference, which takes place every other year in different parts of the world. And as I said, together with members, we developed CAN to be future-proof, namely CAN FD and namely CAN XL. So as such, as a non-profit organization related to CAN, our main focus is our specifications, our CiA specifications, and all of our other products and services are organized around those specifications. So on the technical side, we provide seminars. On the marketing side, we provide our CAN newsletter. And in the future, we have our International CAN Conference, as mentioned. And yeah, as presentation, we are present on many industry conferences. We are organized at Canon Automation in different technical groups. That is just a short overview on them. So you see we have technical groups related to different higher layer protocols, and we can open for the CAN-based or CAN-CC-based protocols. We have CANopen FD for CAN-FD higher layer, for CAN-FD-based higher layer protocol. And then we have we work on different profiles related to I/O devices, drives and motion controllers, measuring devices, and the list goes on and on. And as I said, we also work on the different lower layers, namely in the past CAN-FD, today on CAN-XL, and on CAN-FD Lite. We have also some physical work going on at the transceiver level. And of course, we have dedicated working groups on safety and security. Currently, we have the working group on functional safety, and missing on the slide is specifically on cybersecurity. We provide different publications. As I said, we have the CAN newsletter, which you can download from our website. We provide different product guides, and as I said, we have a website as many other organizations as well, where we provide lots of information, especially in our CAN knowledge base. You can also provide subscribe to our email services. Yeah, that is again just a short overview on the different topics which I mentioned already. And as I said, you can subscribe to our newsletter by writing an email to mail@CanCiA.org, or even at our generic email address at headquarters@CanCiA.org. Of course, we provide additional membership benefits for our members, so they get access to all the specifications we release. They have the ability to influence upcoming specifications by working directly in the working groups. And they are also able to participate in our plug fests. We had different plug fests in the past for CAN-FD, for CAN-XL, for lift applications, and many other such topics and areas. You can also participate in many of our other activities at a reduced fee as a member. Going to the original topic of today's webinar on functional safety. I have here the timeline for functional safety. Some of you may remember in the mid-90s, in Europe, we had the EN 954, which defined some safety requirements for industrial use. From there on, many ideas have developed that led to the publication, to the definition and standardization of the IEC 61508, which today contains several guidelines on a normative level and as well as on an informative level on things which I have to cover if I want to implement a device or system for functional safety. Things which I have to think about how to make my system basically safe. At the same time around, the ISO specification was published for machine safety. And at that time around, we also started and had worked on safety for CAN-based systems, namely specifically for our higher layer protocol CANopen. So we released the specification for that, which is called CANopen Safety. We released it at the end of the last century, and on request by some members, we try to get that published as an international and European standard. But as you can see, it took some time until that was successful. Over the time in between, it developed the German Organization for Industrial Safety in the Berufsgenossenschaft published the GSET 26. That's a specification on how you have to cover safety in your production facilities, on your shop floor. So any company who has a shop floor has to follow that in Germany. Unfortunately, till today, this specification is only available in German language. That's it. Also on the international level, safety, functional safety definitions, requirements, things you need to cover have been developed. And in 2006, in Europe in general, the machine directive was published and became basically mandatory in any European member state. As it was a directive, each member state had to bring that into national law, which for some European countries took some time, but in general, it was being mandatory in any European member state. Over the time, safety specifications have developed. I have to specifically name the IEC 61784-3. That is the series for, in general, this IEC series is for field bus communication, for all field bus communication networks, excluding CAN. But part 3 had the definitions and general requirements for all field bus communications in functional safety, for functional safety communication. So that is also relevant for CAN-based safety communication. And all this had to be, I also worked on those basics over the time in the expert groups, together with experts from Siemens and other companies. And it took until 2010 as CANopen Safety, then was finally released as a European standard. Time goes by, and now we have the EU regulation, the machine regulation. It was published in 2023 and became active, I think, in July last year, but only partly. It will become active in full in starting 2027. So until 2027, there is a time where functions safe systems, according to the machine directive and all the specifications, can be brought to market, but everything's had to follow the new regulations begin with the year 2027. So what does the machine regulation states, or what is the definitions for that? And as we can read it, it states that functional safety in the context of the EU machine regulation refers to the safety that depends on the correct function of a control system. So we have to remember the safety depends on the correct functioning of the control system, and that it is a critical aspect of the EU health and safety requirements, ensuring that machines operate safely and poses no hazard to users or the environment. So functional safety is basically that it should pose no hazards to the user and the environment. And so the regulation outlines then the requirements, emphasizes the importance of risk assessment. So that means from the system point of view, I'm responsible that my system poses no hazard to users or the environment. Sorry. Oops, sorry. And for that, I have to do a risk assessment. And with the risk assessment, I have to take actions to reduce the risk associated with the machinery with my system. And the goal is of the regulation is basically to protect both the public and the workers. So that is functional safety about. So first level, I would say that is a big end goal, so that my system should not harm any user and as well as not the environment. So what are the key principles on that? The key principles are that the machinery must be designed and constructed with safety in mind. That is being done through a risk assessment to identify all the potential hazards to ensure the compliance with health and safety. And then, of course, I have to test and to make some certification with a notified body that, so basically to show that my machinery, my system doesn't pose any hazards to the users and the environment. So that's the general definition. Now we have to look on what and how does it relate to our system, to our devices, and in terms of CAN-based system, of course, on what does it mean in terms of communication in a CAN-based system. With that, I already said we are, as CAN Automations, have worked on, and we have now 3 generations of CAN. We have the original CAN, which we call these days CAN-CC, published in 1986. We have CAN-FD, published in 2012. And we have now also CAN-XL published in 2021. If I look closely on those 3 different generations of CAN and look closely at the CAN data frame, if I don't see look closely on the data frame, then we see the general structure is always the same in any CAN-based system. We have an arbitration field to find where we arbitrate on or how to find and to find the device who is able to communicate its data. We have some control information, and then we have the data field, which over the time increased, and then we have some additional CRC and acknowledgement taking place. First, I want to start with original CAN, with the CAN-CC. What do we have in terms of CAN-CC? What functional safety solutions which may fulfill the requirements of the machine regulations? In terms of CAN-CC, I have here a picture taken from CANopen safety. And the idea in CANopen safety, also in J1939 safety, is basically I have my network with all the different nodes, and we have some regular CAN devices, CAN nodes in the network, and we have some devices in the network which needs to be implemented according to the requirements for functional safety, like emergency button, like I/O devices, or even like safety power switches to shut down a drive, an electrical drive, and the like. So in a CANopen-based system, we have also a PLC which normally controls all devices, but maybe the safety devices want to communicate without a PLC in between, because implementing safety functions in a PLC is taking basically a bit more effort, and with that associated more costs. As I said, based for CAN-CC, for classical CAN, we have for CANopen a safety protocol, and we have a safety protocol for the SAE J1939. And we try, and as I said short before, we have the general requirement for field bus communication, for safe field bus communication. The general requirement is written down and specified in the IEC 61784-3. But the thing with the original definition is that this is intended and written for safety communication in the black channel principle. So that means we have our functional safety, functional safety protocol, functional safety communication profile, or in short, safety communication layer is using lower layers, and it doesn't care about what is being provided in terms of error detection and other capabilities on the lower layers. Everything must be safe within the safety communication layer. So it follows basically it makes the definitions for black channel. The specification also leaves a point open for what I like to call white channel communication, but doesn't make strict requirements on those side. With CANopen safety, we based the definitions on this IEC 61784-3, but we haven't used the black channel approach, but we have used the white channel approach, or sometimes what I more like to say about is a gray channel approach. In general, that means for CANopen safety, we are not allowed to have any gateways and routers and the like in the lower layer. Any such device, any such active device in the lower layers needs to be implemented or needs to implement the complete functional safety protocol, and which makes it much more expensive and much more complicated. So in general, the idea for CANopen safety is to use it for simple system as shown before, and we have no gateways and routers and anything else on the network. So with CANopen safety, we utilize the reliability of CAN. Especially with CANopen safety, we want to have simple implementations without the need of an additional CRC. As shown before, CANopen safety was released at the end of last century, was the time before we had ARM RISC processors and the like. We had slow 8-bit controllers, we had expensive 16-bit controllers. CRC implementations were very expensive, and so we tried to find a solution which doesn't require those expensive requirements. And we wanted to have a small footprint. And so we thought about that, and we came up with a somehow simple solution. The requirement is still that we require 2 CAN controllers in a CANopen safety device, that we require 2 CAN controllers, and the CANopen safety implementation must be redundant in some way, redundantly implemented into the device. The communication is, or the protocol definition is very simple. The requirement was the implementation, the communication protocol should be very simple. And it is as simple as this. There's in CANopen safety, we transmit to our safety relevant data in 2 CAN messages. We have a first CAN data frame where the original data is being transmitted in a message with 1 or up to 8 bytes. And we have a second message, and the second message on the second CAN identifier contains the same data, but bitwise inverted. So the protocol definition is very simple on this. We don't need any CRC and the like. On the receiving side, On the receiving side, we just need to compare the received CAN frames. And we know that the data from the second CAN frame is bitwise inverted. And as we make the comparison, we need to look at this. And when we everything is fine, then we know the communication was correct and is not corrupted. Speaking of, the implementation is simple and the protocol is simple. We still have some additional requirements, and that means we have an additional timing requirement. Additional timing requirement means that as we transmit both messages as fast as possible from the transmitting side, we maybe have a delay between the reception of the second message related to the first one, because maybe other messages are being transmitted in between. So that means on the receiving side, we have a timeout running with the reception of the first message. And within this timeout, within the what we call safety relevant validation time, the second message must be received. And if it's not received within the defined time, then this is considered as a safety event. And my device knows something happened on the network, and I have to react accordingly. On the other side, we have to transmit periodically with what we call refresh time, our data. So we transmit periodically that, like for example, the I/O input or the emergency button is not pressed, not pressed, not pressed, not pressed, and so on. And we transmit that with the refresh time. And on the receiving side, we have to monitor with what we call the safety cycle time. We have to monitor that the data is being received correctly. And when the time is being expired again, we have a safety event, and our device has now to do something with that. Either it is what the device has to do is not defined from the protocol point of view, because that is basically application relevant. So and it also and it's also not any device can follow with the very same reaction. It is also depending on the system. So the system, like an I/O device, maybe needs to put an output too high or needs to put an output too low, depending on the system requirements. So that the system integrator basically then has to define what needs to be done in case a safety event has happened. With those definitions, we fulfill all the requirements for functional safe communication. So that means we can detect any repetition, we can detect lost data, we can detect inserted data, we can detect wrong sequence, we can detect corrupted data, we can detect delayed data. For that, we have our timeout definitions. And we also can, we are able to detect coupling data. Coupling data means, as I showed, we have non-safety related communication and safety related communication on the very same network. It could happen, or it may happen that there is some relation on that, because if a faulty normal regular device would transmit on the wrong CAN identifiers, then that can be detected on the safety side, because we are using two CAN messages with different CAN IDs. And we have proven this with some external organization and with a notified body that this is safe. And we have proven that this is safe for requirements up to safety integrity level 2 and 3 systems. So basically up to safety integrity level 3 based systems, which have the requirements of residual error probability of 7 in the power of 10 in the power of -9. And we fulfill all those requirements. In the past, we have released a reference design based on a 16-bit microcontroller that was done before ARM Cortex chips were available on the market. It was pre-certified and was simple for sensors and actuators. We do not support that anymore because the underlying microcontroller is not anymore available. And with ARM Cortex available these days, there are different actors on the market who can provide CANopen safety much more easily and much more cheaper than it was possible in the past. So what's about J9039? If you want also a good article on that, there is a QR code leading you to the CAN newsletter of June 2024, where there is also a detailed article on the J9039 safety implementation. As you see, the general requirements was the same or is the same. The applications requirements are a little more different as CANopen is more for industrial systems and J9039 is something we see more in off-road vehicles. We can see there are some similarities with CANopen safety. In J9039, we have a safety header message, which is always 8-byte, which contains a sequence number, a reference to the safety data message, and an additional CRC. And then we have the safety data message, which is like a regular PGM, which you may know from J9039, but it makes it safety because of the safety header message. Then in J9039, from the general point of view, we have the very same timing requirements. Fortunately, we have the same definitions of SRBT and SCT, so you can see who learned from whom. And of course, J9039 fulfills the same safety requirements on communication. If we look forward, I mentioned we have now CANFD available for some time. What functional safety communications do we have on CANFD? And if we look closely here, then I have to say that in functional safe in CANFD-based networks, of course, I can use the regular CANopen safety. I can use the regular SAE J9039 safety. Right now, from the CANopen point of view, we don't have a dedicated solution for CANFD-based networks, but as it is backward compatible with classic CANopen, of course, CANopen safety can be used. The same basically applies for SAE J9039. There is in J9039, there are definitions on how to use it on CANFD, the regular and existing J9039, but and of course I can also use the safety definitions here. What's about CANXL? And in terms of CANXL, I have to say CANXL is still quite new. Again, we have no CANopen definitions for CANXL. We have no, there is no J9039 definitions for CANXL, and as such, there is currently no safety. But I also have to mention what will come up with the new machine directive, with the new machine regulations and the requirements. As I said, we have the new machine regulation has an additional focus on remote monitoring in terms of security and remote software updates also in terms of security. I said we have no dedicated solution for CANXL right now, and also no really dedicated solution for CANFD. We are working on in our working group on finding solutions for that. There are still questions in, do we again also want to have a white channel solution, which makes again implementation much more simpler on the device level, on the system level, but as but makes it much more complex if I want to introduce gateway routers and the like, or do we want to have a black channel solution with real end-to-end communication where I don't care about routers, gateways, and other communication devices in between, but of course makes the implementation on the device level much more complicated. I said some differences on the existing machine directive versus the new regulations. The regulation has become immediately effective, so no national laws are required. The main innovations is the coverage of new risks, the reassessment of high-risk machines. So that means in the past, if I made a machine or a system and it's a high-risk machine, then it doesn't matter. I had my assessment and I could place it on the market. With the new machine regulation, it is required that I have a reassessment regularly. I have to do a reassessment regularly and have to consider the changing environment where my machine is being used and have to look, does it still fulfill all the requirements in terms of safety? It also is a reduction of paper-based documentation, so which basically means we have more digital documentation on that. Another big topic for the regulation is the advances into new risk machineries, like human-robot collaborations, or short cobots, in all the machines connected to the internet, in software updates, and especially also autonomous machines and remote monitoring stations. Especially with machinery with autonomous behavior, it must be considered that the manufacturers are responsible for those systems they put on the market or in service. And the assessment must be carried out with regard to health and safety as regularly. But the thing is, especially with the new advances and maybe self-autonomous behavior, which includes machine learning and like, the manufacturer has to cover that, and that's the reason why there is also a reassessment required for high-risk machines. And I would consider autonomous behavior in that area, that it must be the reassessment needs to recognize that the market is evolving, that the autonomous behavior is evolving, and I have to look that the safety is still fulfilled in all those requirements. Another big topic in safety is the IT security requirements, especially with connected devices, connected to internet, connected in terms of allowing over the air updates, software updates, includes monitoring and the like. So I have to consider for my safety function also cybersecurity risk. So that means if a cybersecurity incident happened to my machine, the safety of the machine should not degrade. So I have to look and I have to design my system, my devices, my machine, my system in a way that even a security incident doesn't degrade the safety functionality of my system. And I have, it is also that in terms of software updates, if I allow remote software updates, I have to verify that the software cannot change in a way that the functional safety or the safety systems of my system, of my devices, of my system is being interrupted with wrong software and like. I said we work on on the new requirements, and we have industrial our interest group functional or our special interest group functional safety. You are we are still working on the new and upcoming topics. As I said, CANopen safety for classical CAN is set and working, but we are still working on the upcoming topics. And if you want to join, you are happily invited to bring your expertise onto the table. And with that, I want to close out my presentation, my webinar on functional safety. And if you have any specific questions, I happily invite you. You can ask your questions in the chat, and or if you want to unmute yourself. And I see we have a first question. CANopen safety currently does not cover CANXL. That's right. That's what I said. With 6.11 part 1, there is a tunneling CCFD via XL frames. So although it doesn't benefit from bigger payload, CANopen safety should be usable in XL. Yes and no. From one point, I would agree on that. So technically, yes, it should be possible also to be used as a generic CAN message on CANXL. The only problem with that is, as we make use of the error detection mechanisms in classical CAN and the proven capabilities there, we have no such proven values for CANXL, even while CANXL, from the feeling of my guts, is much more safer than classical CAN. I need proven values from safety experts, from some basically from a notified body with the numbers on what are the real error probabilities for CANXL and the same for CANXL-based system. And without having those available, it is difficult to give a judge and to say, yeah, that can be used. So from the technical point, I agree. I would also agree from my feeling that it is possible to use for safety functions, but it's not proven. That's the difficult. So I have another one. Can you please expand the topic about gray channel? Why did you call it? Yeah, I call it a gray channel because if we look closely, if I switch back to here, in a real white channel solution, the safety layer would be on top of the physical layer. So the safety communication implements all the requirements regarding safety. But for CANopen safety and also for J9013 safety, we make use of some definitions of which are provided by CAN. So we have the CRCs of the CAN message itself, and also all the other features like bit monitoring and the like. And this gives us the benefit that we have some error probability, which is being provided. So some parts of safety, I would say, is being implemented by the data link layer already, and we build on those. And then we still, but that doesn't fulfill all the requirements for safety integrity level 2, and especially not for 3. We have to add additional things. And the additional things is the second message, it's the cross-checking, or in terms of J9039, it's also an additional CRC. And so it's not, if it would be a white channel, we could just rely on the mechanism provided by the data link layer. But as we have to add something, I would more call it a gray channel in that regard. I have another one. Am I understand correctly that J9039 has more error detection measures than standard CANopen and would therefore be better suited? That is not completely correct. J9039, as said, provides a CRC, but that is only very small CRC in that regards. If I remember correctly, it's a 4-bit CRC. And yeah, and there is, to my knowledge, it is not, it is a functional safety. It is, but it is not proven and recognized by a notified body for CIL3 applications. But it is approved for use in some off-road applications. And then to verify the performance level, it must be calculated. So far, we've tried with the GSET26. Are there better newer standards that should be used to calculate the performance level? No, there are no actual. There are the. If I go back to the available standards. So we have for field bus communications that is intended more for safety integrity level definitions. That is the 61784-3. And of course, the IEC 61508 in its current version. I think that's right now edition 5. And for the performance level part, that's not the GS 8026, it's the ISO specification, which I don't remember right now. So if you write an email to us, I can try to answer your question then afterwards. You can write an email to service at CANCIA, and I will find the right answer to that. Then I have here, if I use CANopen safety telegram on the slave, is it necessary that also the hardware be approved as a safety device or just as a CAN controller with safety stack? So that's a more complex question, I would say. If I want to make a safety device like an emergency push button, I have to have the application developed according to the safety requirements. I have to implement so my whole application on the device according to that. And I have to implement the protocol stack according to that. The hardware itself and the software implementation depends on the hardware I have chosen. So there is no dedicated approval of hardware itself. It is more a question in I have chosen a certain hardware, and now I have to think about if I want to make a software implementation on the hardware side, I have to look on what functionality does my hardware provides. If I have a regular microcontroller with, like, for example, 2 CAN controllers or even just 1 CAN controller, then I have to maybe add a second CAN controller as an external one, and I can do some implementations. And if it's a regular microcontroller, then I have to think about, in terms of safety, I have to think about what can happen on errors in the microcontroller, like the RAM could be corrupted, the flash could be corrupted, the calculations could be wrong, and I have to mitigate those problems with my software, and I have to implement the software accordingly. If I use maybe some microcontroller providers provide dedicated hardware for functional safety, what they have normally is then they either have additional implemented in hardware, additional possibilities to diagnose certain functionalities of the chip about their health status. If they have problems with RAM, flash, or even with the CAN controllers. And if I can make use of those diagnostics functionalities, it makes my software implementation much more easier. The same as other microcontroller providers implement not diagnostics functionalities in hardware, but provide dual CPUs and stuff like that, and run them in a lockstep mode. So that my software is basically run twice, and then I can do some comparison. That makes my software implementation much more easier. So in general, it is not required to have a approved safety hardware, but it makes the implementation on the software side much more easier. Okay, then thank you for joining on our webinar. And everybody, of course, as you could join the webinar, have registered, you will receive the presentation afterwards. And if, as I said, also everybody is still invited. If you have questions, you can send them to us, and I will try to answer them. Thank you.